In just a few months, Voyager 1 will be one light day away from us. Think about that. Light, moving at 186,000 miles per second, will need a full 24 hours to reach a spacecraft we built nearly 50 years ago. If Voyager says hello, we won't hear it until tomorrow. If we answer back, it won't get our reply until the next day. 2 days for a single conversation. Launched in 1977 by NASA, it was never supposed to go this far. And yet today, it's the most distant human-made object in history, drifting through interstellar space, far beyond the planets we grew up memorizing in school. Inside that small, aging machine is the Voyager Golden Record, a time capsule of Earth, of us. Our music, our voices, our hope that someone, somewhere, might one day find it. This isn't just a spacecraft. It's proof that when we dare to explore, our reach can outlast generations and travel so far that even light needs a day to catch up. But what astonishing secrets about deep space and our solar system did Voyager 1 uncover on its epic journey? Let's explore. In 1979, Voyager's first major destination was Jupiter. Jupiter looked majestic, but up close, it was chaos. Its great red spot was a storm larger than Earth, raging for centuries. Lightning flashed in its thick atmosphere. Radiation belts screamed with intensity. A place so hostile it could fry electronics in moments. But Voyager's most shocking discovery wasn't Jupiter itself. It was one of its moons, Io. It looked small and unremarkable from afar. Scientists assumed it was geologically cold and dead, but they were wrong. Voyager captured images of enormous plumes erupting from Io's surface, volcanoes blasting sulfur hundreds of miles into space. This wasn't ancient lava frozen in time. This was active, explosive geology happening right now. For the first time in history, humanity saw volcanic activity beyond Earth. In one discovery, our solar system became dynamic instead of static. Space wasn't frozen, it was alive. Next came Saturn. If Jupiter was chaos, Saturn was elegance. At least, that's what we thought. From telescopes on Earth, Saturn's rings looked like smooth, solid bands. Clean, perfect, symmetrical. Voyager shattered that illusion. The rings weren't single bands. They were thousands of icy ringlets, thin, braided, sculpted by gravity. Some no thicker than a few dozen feet. Tiny moons carved gaps like celestial shepherds. Invisible gravitational forces shaped patterns more intricate than lace. Beauty, it turned out, was complexity. And complexity meant motion. Then Voyager studied Titan. Titan was hidden beneath a thick orange haze, an atmosphere denser than Earth's. Beneath that haze were rivers, lakes, rain. Not of water, but methane. A world with weather. A world with chemistry. And where there is chemistry, scientists begin to whisper a dangerous word: possibility. Years after its planetary encounters, Voyager received an unexpected instruction: turn around. From nearly 4 billion miles away, it aimed its camera back toward the inner solar system, toward home. And take the picture. And the result was pale blue dot. Earth appears as a tiny speck in a sunbeam, less than a pixel wide. Every human who ever lived on that dot. That image didn't just change astronomy, it changed perspective. It forced us to confront something uncomfortable. We are not the center. We are not large. We are a fragile species clinging to a dust mote in an endless dark. And yet, we dared to look back. After Saturn, Voyager's journey became quieter. No more grand planetary flybys, just distance. More distance than the human mind comfortably understands. Eventually, it approached a boundary called the heliopause, the edge of the sun's influence. Inside this bubble, solar wind from our star dominates. Beyond it lies interstellar space. For decades, scientists debated what that crossing would look like. Would the magnetic field flip dramatically? Would radiation spike? Would there be a clear, violent boundary? In 2012, Voyager crossed it. Cosmic radiation levels jumped sharply. A clear signal. It had left the sun's protective shield. But the magnetic field didn't twist as dramatically as expected. It was subtler, stranger. And then came another surprise. Voyager detected plasma waves, a faint vibration in interstellar space, like a hum. Space wasn't silent, it resonated. The void wasn't empty, it was structured. The darkness wasn't dead, it was active. Voyager's power source is a radioisotope thermoelectric generator. It converts heat from radioactive decay into electricity. There are no solar panels out there. The sun is too faint. Every year, that power decreases slightly. Every year, NASA turns off another instrument. It's like shutting off lights in a distant house. First the heaters, then certain sensors, then backups. In 2022, something alarming happened. Voyager began sending back garbled data, random numbers, confusing telemetry. Not silence, nonsense. Engineers on Earth had to diagnose the problem across more than 14 billion miles. Every command they sent took about 22 hours to reach the spacecraft, another 22 hours to get a response. Nearly 2 days for a single troubleshooting step. Imagine updating a computer and waiting 48 hours to see if it worked. They discovered corrupted memory in the attitude control system, a small but critical piece of code misplaced. So they rewrote and rerouted commands, carefully, patiently, and Voyager responded. Clear signal, healthy systems. A spacecraft built in the 1970s, still obeying instructions in the 2020s, still listening, still answering. Voyager carries something profoundly human. The Voyager Golden Record, a gold-plated copper disc. It contains greetings in 55 languages. It contains music from around the world, classical compositions, blues, traditional songs. It contains images of DNA, images of families. It contains the sound of wind, thunder, a baby crying, a heartbeat. We didn't just send science into space, we sent emotion. We sent art. We sent identity. If some distant civilization ever finds Voyager millions of years from now, they will know we existed. They will know we wondered. They will know we reached outward instead of inward. Even if no one ever finds it, the act itself defines us. We are a species that leaves messages in the dark. In a few months, Voyager 1 will be more than a light day away from Earth. That means light itself, the fastest thing in the universe, will take 24 hours to reach it. If Voyager stopped working then, we wouldn't know until tomorrow. Its signal is tiny, just 20 watts, less than a refrigerator light bulb. Yet Earth's massive antennas still capture it. That whisper carries data about interstellar plasma, cosmic rays, and magnetic fields. And it carries something more, proof. Proof that a fragile civilization on a small blue planet can build something that survives half a century in deep space. Proof that curiosity can outlast politics. Proof that exploration is not a luxury, it's instinct. One day, its instruments will go dark, its transmitter will fall silent, and there will be a final signal. At first, we won't know it's the last. There will just be nothing. But Voyager will keep moving for millions, maybe billions of years. Long after cities crumble, long after languages evolve, long after our monuments turn to dust, Voyager will drift alone, carrying a golden record, a message from Earth. Proof that we once dared to ask questions, built machines for wonder, and looked into the infinite with curiosity, not fear. Somewhere in the star-filled dark, Voyager 1 keeps going. Not because it was meant to last forever, but because we dared to imagine beyond our lifetime. We are small, we are fragile, and yet we reach. If you enjoyed this video, hit like, share with friends, and subscribe for more amazing content.